Hello, and welcome to ActiveView. I'm Abby Doolittle, and a Vice President in RGA's Global Data and Analytics practice. Today, I hope to demystify artificial intelligence, or AI, by highlighting its origins, explain how it's related to data and analytics, and try to make sense of a few of its many acronyms. Here's a little bit about me to help explain my perspective. As a science fiction fan, I like robots, read and watch movies about robots, but clearly I'm not in robotics. When some people hear the term artificial intelligence, or AI, they may think of robots, or self-driving cars, or similar innovations. I'm more of a number crunching person, and some of you may be as well. Number crunching, or for me, data and analytics, plays a big role in AI. But I want to start by answering, why do we care about AI in insurance? We care because artificial intelligence is critical to business success. This sentiment is echoed in the marketplace. Several independent companies surveyed data and analytic trends in the market. One from Deloitte surveyed over 2,000 IT and business executives and found that 73% of those surveyed believe AI is very or critically important to their business today. The reason AI is critical to business success is the focus of another finding from the same survey, where 64% of respondents said AI technologies enable them to establish a lead over their competitors. Said another way, AI is a competitive advantage. It's a business differentiator in the market. I would argue the benefit of this competitive advantage is likely the greatest for early adopters, as the advantage will evolve over time to become table stakes. This is supported by another finding from the same survey, where 73% agree that AI will be integrated into all enterprise applications within 3 years. And when you think about it, 3 years isn't a lot of time. But why insurance specifically? Well, there are applications of AI to insurance. For a long time, the insurance industry has used data to assess risk, and now with the explosion of consumer technology and other technical applications, it's increased the types of data we have available to assess risk, including both structured and unstructured data. It's an interesting time for insurers as new possibilities and rating factors and products may result, and it's also a very exciting time to be a data scientist. An example of this is the depth and breadth coming from wearables. And the data are increasingly being incorporated as part of both health and life product development. Another example is unstructured data from digital images. It's early, but a number of companies are considering insurance offerings based on facial analytics technology. You can think of underwriting use cases as well for both facial and speech recognition technology. Smoking propensity comes to mind. A fourth example is medical imaging. And my favorite use case or study is the research conducted by the Massachusetts Institute of Technology with Massachusetts General Hospital. They have found they can predict breast cancer from a mammogram as far out as 5 years in the future. This is amazing, and it's fascinating to consider what we can do today and in the very near future, and all the possible applications to insurance, from sales through claims. But I want to point out that just because we can doesn't mean we should. Scientists are actively pursuing research agendas to push the boundary of what's possible, but we need to be mindful of fairness and proxy discrimination in insurance, as well as privacy requirements when we use these new data sources. This is an important topic for continued discussion, but I'll save it for a different time. All that being said, there's also a lot we can do with the final example I present today. Insurance is document rich, be it paper or digital documents. There's a lot of benefit to unlocking data and documents and making insurance processes more efficient. It's also a data source that already exists in companies today. So the win-win of benefit plus availability makes it a good place to start. We'll dive into this in a few minutes. Of course, there are other data sources, but I'll stop here for now. But note that the use case possibilities for insurance from these and other sources span the entire insurance value chain, from sales and marketing to product development to pricing to underwriting to claims. In particular, new data sources for risk calculations in actuarial and underwriting sciences quickly come to mind. This leads us to an insurance trend that is linked to artificial intelligence, where the actuarial, underwriting, and data sciences are converging. One market data point to highlight is that the Society of Actuaries has changed the ASA requirements, which resulted in the addition of a statistics for risk modeling exam and a predictive analytics exam. This is a clear recognition by the SOA that actuarial and data sciences are converging. We see similar evidence of the trend with the growing use of data science and electronic underwriting solutions, as well as with risk data products. But what is AI? Let's start with a very basic definition. AI is artificial intelligence. Machines replicate intelligent human behavior to perform tasks. And this is a very broad definition, and it's a very broad domain. In modern history, experts would say that AI dawned in the 1950s. The first academic AI conference occurred then, as well as the first game-playing program for checkers, where a machine learning program accounted for the high performance of the player. Given it's a wide domain, there are subdomains, and I just spoke to machine learning. What is machine learning? Well, ML or machine learning, a type of AI. And then within machine learning, we have deep learning, which is a type of ML or machine learning. So essentially, deep learning is an analytic technique in the machine learning toolbox, if you will. There are other techniques as well. As a data scientist, I like to think about it like this. With machine learning, you use data with analytic techniques to develop a model algorithm where that algorithm is meant to help make decisions. More efficient decisions, better decisions. And when I think about it like that, I would state that ML is the brain of AI. But of course, there's a lot more going on within AI than ML. How did the AI buzz come to be? 1950s is a little while ago, but even in the last, say, 10, 20 years, there's been a lot of buzz about machine learning and AI. And I would argue that the AI renaissance is fueled by the global digital transformation, with innovation in 3 key areas. I already spoke to new data sources, largely unstructured or semi-structured, from wearables, images, audio, or even paper. And of course, there are also more traditional structured data sources coming from places like operations or transactions. And the amount keeps growing. The International Data Corporation expects that worldwide data will grow to 175 zettabytes by 2025. But in addition to data availability, there's also an innovation in computing power. The most obvious example is cloud computing. Data scientists are able to do a lot more today than, say, when I started out, not just because of the available data and the increasing amount of data, but also due to new technology. So this leads us to the third key area, where we have innovation and algorithm improvements. Deep learning and reinforcement learning techniques would be great examples of advances that add to the data science toolkit. Each of these areas by itself is important, but taken together, the 3 areas really fueled the AI advancement. The whole is truly greater than the sum of its parts in this case. I want to take a moment and speak to a definition of predictive modeling vis-a-vis machine learning. And I am guilty of this, where I will use these terms interchangeably, might even use some of the terms within each area interchangeably. I'll admit from the start that I came from the predictive modeling side, being an applied scientist in the economic space. However, with the advent of technology advances, the explosion of data sources and different types of data, and the new techniques that you could deploy, I'm leaning more and more to the machine learning side. Or if you could say in this diagram or in the picture, I'm part of the movement that's the baby tree being born out of the two areas. But to step back and say, okay, they have different academic roots and a different guiding principle, but they're very similar. Predictive modeling is born out of statistics. The roots are in math. Machine learning is born out of computer science, technology roots. Predictive modeling uses data and technology. Machine learning uses data and math. So you see where I'm going here. Both areas, both expertise and the experts within them use math or statistics, data, and technology. You go a level deeper, and the vocabulary is different, but speaking about the same thing. A dependent variable for a predictive modeler is what a target would be for a machine learning person. Inputs are called independent variables for predictive modeling, whereas inputs are called features for machine learning. Algorithms or models are developed and validated for predictive modeling, whereas on the machine learning side, they're trained and tested. So I would present that, yes, coming from different academic roots, however, using very similar, if not the same toolkit. So they're not only very similar, but they're very much the same underneath. Now, someone on our team would say we can get into a little bit of a geek slap fight about the details, but generally speaking, we can think about it as folks that are practicing machine learning, predictive modeling as being very much the same underneath. I do want to call out the guiding principle down below. Understandably, probability is the guiding principle for predictive modeling, born out of statistics. I think similarly, understandable, automation is the guiding principle born out of computer science for machine learning. And this is really part of what's drawing me more and more to machine learning and machine learning techniques. Let's peek into the black box. Many people think the activities of data scientists all occur in a black box. Data in, model out. I can understand it as we use computers, cloud computing, so it's not easy to show the work. And it's math, data and math. This is especially true in the case of automated machine learning or AutoML. AutoML eliminates some of the iterative, time-consuming tasks in machine learning that a data scientist needs to go through, and instead automates these steps in the model building process. It's a good example of the automation guiding principle of machine learning, as it automates the selection, composition, and parameterization of machine learning models. Pulling back the cover of the black box, you can see some of the detail that a data scientist would walk through in order to put together a machine learning algorithm, be it AutoML or non-AutoML. In this case, we'll speak to AutoML. Automating the machine learning process may provide faster output than non-automated ML approaches. And as you'll see in the picture, activity within the box, black box, or here blue, may be highly automated via AutoML or not, as a data scientist takes a more traditional or less automated approach. I won't get into the details of the different model types or categories and the details of AutoML, as Jeff Heaton has already reviewed this in an earlier ActiveView presentation from September of 2020. I will draw your attention to the fact that not everything can be automated, and sometimes it's not appropriate to apply AutoML only. For example, there may be sparse data situations or use cases where a wrong decision is very costly. This is why one reason I think computers aren't going to take over completely, at least not soon. Human expertise is needed in certain parts of the process, and more so for some situations or use cases than others. Also, complete automation is really hard. And that last, say, 10 to 20% of the work is often the most challenging and often requires human judgment. But let's walk through an example of AutoML since I bring it up. And this is a case of what I would call anomaly detection, which could be applied in a lot of different places in insurance. Here it's applied to underwriting, but you could think of it in claims and in other areas as well, where you're trying to find an anomaly or an error in a process, something that might be out of control if you're a process control person. So the use cases are varied, and the applications of an anomaly detection could be applied to a variety of use cases across the insurance chain, value chain. In this case, you'll see in the bottom right-hand corner that the algorithm detected an anomaly and an alert was generated because a business decision was required. Someone needed to check this out. Otherwise, the process runs. But if something pops up red, either below or above, someone needs to check it out in this case. So digging in a little bit deeper into the details of where else we could go with AI modules. I just spoke to a data anomaly module. But there's two. First, before I get into that, let's at least do this last definition for AI, where there are two categories or two definitional categories of AI, narrow and general. Narrow AI, a machine completes a single task well, or a series of single tasks. So it might look like a complex task from the outside, but it really may be a series of single tasks. And there are a lot of examples today. I just mentioned some here. Modeling, predictive recommendation engines. If you go to Amazon, you'll often get recommendations on what you could buy. I'll talk in a minute about OCR and NLP. General AI, machine exhibits human intelligence. And today, those examples are in fiction. As interesting and as fascinating as some of the literature is on this, we're just not there yet. Going a level deeper into narrow AI examples, I want to call out the fact that I talked a lot about data sources, new data sources, which generate unstructured data for the most part, or semi-structured. In order for the data to essentially be used in a machine learning algorithm, you need it to be structured to some extent, generally. So here I give examples across the top of the different data sources. Some of them I've already talked about: documents, language, chats, voice, video, images, wearables, other IoT devices potentially, and social media, which I'm not going to talk about today. Where I do want to focus is on OCR and NLP, because that is really the most relevant to a lot of insurers seeking to unlock the data in documents. So let's start with documents. I just pulled one here. This is from underwriting. It could be from anything. And clearly it's somewhat legible, and an underwriter through the underwriting process would take a look and pick out the information needed of this and a variety of other documents. Sure would help the efficiency of their process if we could automate the data extraction and put it into a structured format for them. Taking it a bit further, this is an ugly document where it's hard to read. So can we read it better? And here's an example of that being an additional part of the task is really to pull out the data and what the prediction might be. And as pointed out here, it can happen in languages other than the one I'm speaking in right now. So to define OCR, OCR is optical character recognition. And it uses ML. You might hear people use the acronym ML and OCR interchangeably as long as within the context of the definition, which is to essentially convert images that are printed, sometimes handwritten, into machine text, and it's scanned from a document, photo, or PDF. The experts that work in this space include computer science, data science, domain expertise, and there are others as well. But to carry on with the underwriting example, taking a FAC underwriting example here, there are several documents that are referred into the process: an application, lab work, attending physician statements or APS, and then others. And especially depending on where you are in the world, you can be more specific about what that other bucket is. And in underwriting, to take a look at these and manually extract the information, essentially read the information and absorb it and extract it as needed. It would be helpful, though, for the documents that can be used in an OCR process, or go through an OCR process rather, is if we had an AI module that was an OCR module to extract data from those documents before it goes to manual underwriting. There could be another layer to introduce yet another acronym here. Robotic process automation could be a manual as well that layers in like a Lego block, where you're bringing the manual data that's extracted and the OCR data together. And that's if you're capturing the manual data extraction, of course. And then I presented one briefly earlier with the data anomaly detection, but we could have a business intelligence module or a data visualization dashboard, which might also help manual underwriting. So this is all starting from OCR, and the motivation is to try to really extract the data in an efficient way from documents and put it into the underwriting process. But as you see, I'm starting to layer in other AI bits, if you will, or modules that could be used. Natural language processing is the other definition I wanted to pull out of that landscape of unstructured to structured data. And NLP is natural language processing. Also uses ML in order to operate. It's the automated manipulation of natural language speech or text by software. So linguistics is included, computer science, data science, domain expertise. And the way I think about this is that the data are already extracted, but the context might not be well understood or might not be useful at all. Here's an example from automated underwriting, where you have an insurance application that goes through the process, and I just picked out a bit of the process here for the example, where there's a disclosure. Were you hospitalized in the last 5 years? Yes. What is the reason for the hospitalization? Molars taken out. So it goes through the process. Molars taken out as a disclosure. Is that found? Yes. Then it continues through the process to the underwriting recommendation of accepted or declined, et cetera. But if it's not found, you could deploy an NLP module in order to determine, using ML techniques, machine learning within the module, to see if you can extract the context and make better sense of it, essentially. And if you can, then you kick back into the automated underwriting process and ask, do you mean wisdom teeth extraction? Yes. You go on your merry way into the underwriting recommendation. Of course, there's a lot more to this, but just as an example. And then there's always the refer to underwriter kick out. So you can always go to manual underwriting if you can't find the disclosure, or if what you found as a disclosure wasn't the correct one. And you're probably starting to see some of the story here, where you have documents going through a process, underwriting or otherwise. You extract the data from the documents via OCR, and you want to understand the context, and you deploy NLP. So there is an AI trend I want to point out, and you may, in talking to different insurtech companies or vendors in this space, want to ask specifically, is it OCR or NLP or both? I think it's more and more both and converging, because you could use the OCR, as I said, to extract the content, and then you essentially use NLP to make sense of the content. And then that can go into yet another machine learning algorithm. And underneath the hood of these are all machine learning or ML algorithms. And as I said, this is saying it in a different way. You can use OCR and then NLP to structure, clean, and contextualize the data. One example that people use internally is you can extract the word cancer from a document, but without the context of what that means, it's hard to make a good decision. And that's one reason why I think these are converging. Another definition, another acronym, BI. I used it a little bit earlier. BI is business intelligence, otherwise known as data visualization. You're likely very, very familiar with this. It's been around for a while. And it's really the visualization of data and information or insights to help aid business decision-making. And it brings in business analysis experts, user design, I think is important, domain expertise, et cetera. And you might ask why I include BI or data visualization in a talk about AI. Doesn't seem advanced enough to be in the AI bucket. BI's been around for a long time. Business reporting and dashboards are not new. In my opinion, BI is definitely important and sometimes not given enough credit. How are we to know if our machine learning efforts produce value if we're not measuring and communicating results? How will we fund future AI efforts if we can't show results either in top line or bottom line efficiencies? In business, return on investment, or ROI, is an important part of success, and measuring the results of our efforts is an important component to our work. I like to think about it too as BI is the window into the black box, and it really allows the business user the detail of what's going on to some extent. And again, I just pulled out an underwriting example here. If you're using OCR plus NLP, so you can put an APS summary into a dashboard, just mocked up. And I've shown several underwriting examples, and I don't want to leave you with the thought that this only happens in underwriting. I just happen to use those as contextual examples. Here is the use of the same tooling, same AI tooling, OCR, NLP, BI, ML, in treaty digitalization. Similar story. You have paper treaties, they're scanned in. They're mapped, data extracted and mapped using OCR and potentially NLP. It's digitally stored. And then there's a search component where you could have a BI dashboard. We're still focused on locking data in documents, but it's a use case, not just another spot on the insurance value chain that I want to call out, because you can start thinking about all the different applications across the insurance value chain. But it's also an example of how you're starting to layer in the different AI applications to create a stronger solution. And as we evolve our thinking on how best to apply machine learning in various use cases, we can build agnostic AI modules that can be applied to different use cases and different parts of the value chain, which increases the efficiency of deployment. I want to carry this thought further, where incremental success builds a foundation. You layer in modules for success. Now, of course, you have to start with what the business strategy is and the business plan. You need to work with business leaders to determine what the business requirements are. And then you create the roadmap that enables that business strategy. And of course, with value metrics or key performance indicators, KPIs. And in this conceptual diagram, I just propose how to think about layering in your AI modules. Difficulties on the x-axis from low to high, business impact on the y-axis from low to high. And you might want to go right for the gold. You might want high business impact and high difficulty right out of the gate, which is kind of hard. What you really want is low difficulty, high business impact, but unfortunately, that's usually not the case. So understanding that you really want the highest business impact, but when you think about it, again, this is a conceptual example, you might not be able to finish that until 2022, a couple years out. Let's start with a quick win. Might be a low business impact, but it's not that hard. We can get it done fast. Gosh, it would be great if we can bring these out in every 3 months using an agile approach, or even quicker if possible. Finish your first module in late 2020. Build upon that module, which is often needed, you build the foundation anyway to get to module 5. So build that first module, show the value to the business, and then move into the second module. Hopefully, not so long after. It's a little bit higher business impact, a little bit harder, but you're leveraging the work done in the first module. I'm making this up, but here's a third module, which is more difficult, maybe not as much business impact, but it's needed in order to get to the fourth module, which brings you to the fifth module. So think about it as, stair steps. You're really trying to build the foundation to the big win. But if you wait for several years to show value for a big win, you might never get funded for that long. And it's really not the right way to think about it, especially if you have to build the foundation anyway. So my advice is to strive for quick wins using modules that build on each other. And I would develop these modules from an agnostic viewpoint. And that means you're able to use them in different places. And the example goes all the way back to the data anomaly detection, where that AI module can be used in several different places. So you can pave your way to AI success. You want to be proactive. You want to work with the business and have a proactive roadmap. You want to help enable the business success. You don't want to sit back and wait for the business to ask. Ask for an expert to come in and work on a point solution. You want to think about it holistically. You want to be agile. You want to build on incremental successes, build that foundation. I've spoken to not just creating value, measuring business impact, but communicating it as well. And engage. You need to collaborate with experts across your organization. Just because it's machine learning doesn't mean that only data scientists are going to be working on it. These solutions require a cross-functional team. So success really requires multifunctional collaboration with a variety of experts, because this is a big puzzle to put together. The AI roadmap is meant to enable successful business outcomes, and it must therefore support the business strategy and the plan. That means business leaders and domain experts are critical. I would even go as far as to say that there are internal clients and absolutely need to be at the planning table on day one, so we can properly identify the business requirements that then feed into the AI requirements in the roadmap. And then takes experts from different technical disciplines to properly solution and execute the roadmap. Data scientists are, of course, important. And as a data scientist, I would love to say that it is the most important, but I'll admit that's not true. Model development is only one part of the puzzle. Proper implementation with run and maintain, leading to an ROI for the business, is necessary for a successful program. In fact, you may find that there are as many or perhaps even more data engineers and solution architects, as well as data visualization experts, as there are data scientists. And then, of course, you can think of the domain experts, depending on where you're operating, underwriting use case, actuarial use case, claims, et cetera. Executive support is absolutely critical. And I bring this from McKinsey, another company that does a lot of research in the data and analytics market. And there are several practices that they state. I pulled out the top 3. I think these are not, in my mind, they're not necessarily prioritized. You need all of them. But the top 3 practices by AI teams that differentiate a high-performing team from others. Senior management fully committed to the AI strategy. An AI roadmap clearly prioritizes the initiatives that are linked to business value across the organization. And the AI strategy aligns with a broader corporate strategy. These are critical. Grassroots initiatives from an AI perspective are really, really hard. I've been there before. To really get moving and realize that competitive advantage that I spoke to at the beginning of the talk, you need to have someone championing you and your team. It truly takes a multifunctional team of experts to run a program. Humans will continue to find new and innovative ways to use data, technology, and algorithms to expand the science in partnership with the machines. I thank you for your time. Please feel free to reach out directly to me or to RGA if you have any questions. I always love to talk shop.